21 for you. Remember, we're trying to find the derivative. So to do that, we're going to use our definition of derivative. And where h represents the change in x. So now I need to plug this in to my various formulas, or to my function. X plus h goes in where the x is. I'm going to change colors. 1 over x plus h minus 1 minus 1 over x minus 1, and all of that over h. So now at this point I need to get a common denominator here. So I'm going to go to another page real quick just for space. Sorry. My common denominator, okay, I had to pause it for a sec, sorry. As I was saying, I need to get a common denominator. There isn't going to be a nice one here. So what I'm going to do is simply multiply this fraction by the other denominator. It's going to look clunky for a while, but eventually it's all going to kind of work itself out. So this becomes x minus 1 minus x plus h minus 1 all over x minus 1 times x plus h minus 1. My numerator is going to simplify. Denominator is not. I'm going to leave the denominator where it is. The x's cancel out, the 1's cancel out, and I'm left with a negative h in the numerator. So going back to the other page, I get a negative h all over x plus h minus 1 times x minus 1. Now using our properties of fractions, that denominator is going to go on the bottom. So my limit becomes negative h over h, or the opposite of h, times h plus x plus h minus 1 times x minus 1. Now these h's will cancel. So those cancel out. I've got to go to a new page. So now I have the limit as h goes to 0 of negative 1 all over x plus h minus 1 times x minus 1. When I evaluate this limit with substitution, I plug in 0 for h, and I end up with x minus 1 times x minus 1 in the denominator, which can be simplified even further and written like this. And that is the derivative, or the generic equation that would help us to find the slope of the tangent line at any given point on that curve.